Hello. Hi, everyone. Good morning.
Good morning, ma'am.
Hi, good
Yeah.
morning.
Hi, Shweta.
Hi, ma'am. Good morning.
Good morning. So today we are going to have a small mock. Okay. Till now we have completed digital logic design and Verilog HDL, right? So we have designed different types of circuits in behavioral modeling, data flow, gate level, and structural. For combinational logic circuits, sequential flip-flops, latches, and registers. We have designed different types of registers and different types of counters with the problem statements and finite state missions, melee, more for different problem statements. And also we have designed memories, right? So from these, so we'll have a small mock, okay, so that we can understand up to where you have learned and so that where you are lagging and what are areas you need to update yourself, like in writing the test benches or whether you are writing the logic properly or not. Okay. So theory everyone can understand because whatever we did the assignments till now, every assignment is problem statements, writing the programs. Okay, logical program building like that, right? So almost a theory, I think, okay, properly. So first 30 minutes we will concentrate on theory part. So we will discuss all the theory questions, revise all the theory, and then just we will try to write a small piece of code. Okay. So first we will start with Jerin. How are you? Did you revise all the concepts?
I mean, went through whatever was possible. I have some concepts left to go through, but I'll try.
Okay, fine, fine, no problem. You can try. First, we will start with the Verilog HDL. Okay. So in Verilog HDL, first question is for Jeevita. So in Verilog HDL, what is the difference between synthesis and simulation?
In simulation, where we will apply test input to test the design functionality, synthesis will convert design code into gate level netlist.
Okay. So what are the limitations we are facing in Verilog HDL for simulation?
In sometimes, for example, in case statement, if you don't specify default statement, there we will see kind of simulation and synthesis mismatches.
Okay. In terms of test bench, like if there are limitations in Verilog, then only we are planning to move system Verilog, right? So while we are writing the test bench, what are the limitations we have faced?
No idea.
No idea. We have discussed,
No.
right? Hard-coded values, assigning hard-coded values with rand keyword. Randomization is not possible in Verilog HDL. And
Okay.
Verilog is dynamic, Verilog is static in nature. Have you remembered that?
Yeah, a little bit, not completely.
Okay. Jarin, can you answer what are the limitations we are facing in Verilog HDL and why we are moving to system Verilog? Just we didn't discuss system Verilog, not yet started, even demo session. Just you can explain in terms of Verilog.
Mm, First point that I recollect is about the randomization. In Verilog, we need to, while providing the stimulus, we need to specifically hard code the values. So for bigger size variables, which is like 16-bit, 32-bit values, we'll have to provide those many times inputs uh, during mentioning in the test bench. Whereas in system Verilog, we can do that with the help of randomization. We can generate random variables to test the corner cases.
Okay, okay. So basically, Verilog HDL is a simple program. We can write a test bench in very simple, like just in 20 lines, 15 lines, we can complete the test bench. But whatever the corner case scenarios we are verifying, we cannot take all the scenarios. Suppose you are verifying 32-bit address and 32-bit data, it is very difficult to generate the values to for 32-bit, right? To power 32 number of values we need to generate, okay, directly manually. But most of the cases we don't use the 2 power 32 values. Why? Because there is no need in terms of practical. If you go with the specification wise, maybe 0 to 100 or 200 to 500, only those values requirement will be there. But if we go to the complex applications in project level, we need to generate all scenarios. 2 power 32 scenarios we need to generate. Okay, so 2 power 32 number of scenarios we cannot do the manually. We cannot generate manually, like address equal to 0, address equal to 1, address equal to 2, address equal to 3, like that we cannot assign the values, hard coded values. Okay, so in Verilog HDL, we have randomization, dollar random. By using the dollar random, we can do the randomization. But dollar random having lot of limitations in Verilog HDL, where in system Verilog we have randomized method. Before I told you, in Verilog HDL, if there are 10 number of inputs like address, data one, write read signal, and some reset signal, and 10 number of input data are there. So whenever you want to assign the input data to all the signals, every time you need to write data 1 equal to dollar random, data 2 equal to dollar random, data 3 equal to dollar random, data 4 equal to dollar random, data 5 equal to dollar random. Like that, for every variable we need to assign dollar random. In that also, if you want to control, we have written for simple generating even odd values and multiples of 3, multiples of 5 using dollar random, right? That is possible, but is not, that is not good style, because if there are 10 number of variables, 10 times we need to write assign dollar random for each variable. But this limitation we are going to avoid in Verilog, in system Verilog, by using the methods. Everything we write in terms of object oriented programming in system Verilog. Okay, we create the object for class. Whatever these 10 variables are there, these 10 variables we put into the class. Okay, by using the object, we are going to use a single method, just object dot randomize for transaction class. By using that just a single line, even we can randomize 100 different variables at a time. Okay, so that is what the benefit of system Verilog randomization. Even we can control the randomization there. Suppose I have explained before. Suppose in the specification you have only few requirements, like there are commands for some calculator project. Okay, uh, command 0 means no operation, command 1 means addition, command 2 means subtraction, command 5 means shift left, command 6 means shift right. So if you declare command size as a 32-bit size or even 4-bit size, in that 4-bit size, our requirement is only 5 commands: 0, 1, 2, 5, 6. Okay, only these commands only we need to generate as a input values. Okay, if you generate other value, suppose you are generating 3, 4, 7, 8, 9, 10. there is no use of generating those values. Why? Because we are not doing any operation for that command, right? We are doing operation only for these commands, 0, 1, 2, 5, 6. So according to that, we need to generate the input scenarios. Okay. If you generate other scenarios, no use. Even for coverage also, no use. Okay. So this is what controllability we can do in a system Verilog. Okay. And also we have another limitation in Verilog HDL, that is, while we are doing the randomization, if you are doing a 3-bit size randomization, within 3-bit, it will generate multiple number of repeated values at a time. Okay. I have shown you the example also, repeating several times. Okay, but that is not happened in the system Verilog, because we have in system Verilog we have two type of cases using RAND and RAND-C. We call, once we start the system Verilog, you will understand the concept clearly. So the difference between RAND and RAND-C is we don't generate the repeated values within the range. Okay, so that what is the benefit of that? We can generate more scenarios. Okay, suppose there is suppose there is a 3-bit data. 3-bit data means how many cases it will generate? 8 number of cases it will generating. Okay, so in repeat you are writing repeat 10 number of times, data equal to dollar random. Now this data is doing randomization is equal to dollar random you are writing. Okay. Now this data is doing dollar randomization, and it will generate the values within the range. The range is between 0 to 3 or 0 to 2, 3-bit size, right? So it will generate 0 to 7 values. But because of dollar random, it will generate the values randomly. So first it may generate 6, then 5, and then 2, and then 2 again, and then 6 again, and then 3, and then 0, and then 1, and then 2 again. So how many cases completed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Excuse me, ma'am.
Hello?
I don't think you're sharing your screen if you are.
Okay, wait.
Yeah.
Okay, see here. 8-bit size. Suppose data is 3-bit size. 3-bit size means 8 scenarios will be there. Okay. I am writing the Verilog program, repeat of 10 times, data equal to dollar random. Okay. So that it will do the randomization, and for data it will assign 10 different values. Okay. So values are generating between 0 to 7. Okay. So what values it will generate? Randomly, not serially. 0 to 7, right? So it is generating 6, 5, 2, 2 times repeating 4, 3, 6 again repeating 1, 2, 2. So total 10 number of times, because we are repeating 10 number of times. Okay. Now, if you observe here properly, 6, 5, 2 is generating 2 times here, and 3 times and 4 times. Okay, like that 6 is generating here 2 times. Okay, because of these repeated values, what is the limitation? Instead of repeating these values, we can cover other scenarios, right? Still there are some more scenarios which we didn't cover. Like suppose we didn't covered 7 value, and 0 value we didn't covered. 1, 2, 3, 4, 5, 6, 7, 0. Okay, here in this case, 2 values are not covering. Okay, so if we write in system Verilog, we have an advantage of generating all in a cyclic manner. Okay, so we don't get these repeated values. If we get the repeated values, we are just wasting other scenarios. Instead of even it is generated single time also, that case is verified. Okay, no need to generate multiple number of times. So without generating multiple number of times, we can verify another scenario. Okay, so this is what the limitation with the Verilog HDL. Okay, clear everyone?
Yes.
And
Yes.
also, in terms of verification, if we connect with a SOC level or IP level, because in real time, we work everything with the different types of subsystems and different types of IPs, right? Where we connect all the functional blocks in a digital logic design at one. Okay, we don't verify individually, even though we verify individually, but finally at top level we need to connect everything at one place. Okay, so whenever we are connecting all these things, Verilog never used. Why? Because Verilog we can't use dynamically, because if you want to connect one block to another block, it requires nearly thousands lakhs of signals. If you want to generate thousand lakhs of signals using Verilog HDL, it is very difficult. Okay, so for that purpose, we cannot generate these. We cannot generate using Verilog HDL. Okay, where
Could
system
you
will
repeat that part?
dynamic.
You said dynamically. I didn't
Yeah,
understand that part.
dynamic in the sense we do the class based verification. Class based verification in the sense every time we change in the runtime. Before I have explained, whenever we write the test cases, it have some runtime. Runtime in the sense some test cases will complete in 1 hour the run, and some test cases will complete 1 week, within a week. Okay, so whatever the time duration is there, we call it as a runtime. If you want to make any changes of the test bench, we can make the changes in runtime if it is a dynamic in nature. But if it is a static in nature, we cannot change in runtime. If you don't change in runtime, what happens? Suppose a test is there, test is running for 1 week. Okay, before that, meanwhile it is running for 1 week, we have some modifications for the test. We need to do some modifications internally. Okay, so after doing that modifications, you need to terminate this test and run again. Suppose this test is still running in fourth day, that 4 days of time is wasted, right? If you terminate and rerun again it will take 4 days extra. Okay, so without happening that, we can change everything in the runtime. That means whenever the test is running, whenever it is following the stages, okay, whenever the test is executing, it will follow number of stages. Okay,
And so,
like
sorry to interrupt.
first test
Yeah.
execution stage. Okay, main stage, it will enter into the test main functionality. Like that, stages will be there. Okay, so that it will come into the whatever the change we made, the modification, it will reflect to the test. Okay, yeah,
Right.
tell me, what is your doubt?
Like for example, like sometimes a few big synthesis or some designs take like 4 or 5 hours to synthesize.
Hmm.
So even test bench is also getting synthesized with the design. So does that mean that let's say we want to change some value that we want to give as a stimulus for the design, so we would have to resynthesize it, the test bench. But if you use system Verilog, we don't have to resynthesize.
Here, okay. Anyway, the test bench, whatever we are running, it will run with respect to synthesis only, with respect to the RTL design. But whatever we make changes in test bench, that will reflect to the functionality RTL also. Okay, the connections, whatever we make, the DUT, both will be connected and it will make the changes both.
So we can't dynamically change the inputs. And like, can we skip resynthesizing the design if we want to change the inputs? Or do we have to like synthesize again if we change the test bench?
See, synthesis is different here. We are talking in terms of verification point of view. Synthesis, if you want to do that, we can do. Synthesis is different, and test bench verification is different. Here we are running test cases. We are not resynthesizing here.
But I thought we were synthesizing the test bench also when we run the code.
Okay, but synthesis is not verification part. That will be done in the RTL design with the RTL design engineers. Whatever the modifications are there, they will take care of that modifications. Whatever the modifications they did, according to the verification, we need to add the functionality. We need to add the test for that modifications. Okay, so we don't
Right.
resynthesize or we don't synthesize the RTL design. Even we don't make the changes of RTL design. As a verification engineer, we make only test changes because regularly we will get the updates from the RTL team, CDC team, and there will be different connection teams will be there, right? If you go with a post silicon verification DFD, it will be connected with the all different teams internally. Regularly we will get some modifications for every week regressions. Okay, so whenever
Right.
we are doing that, we will take care of our test. We will make the modifications accordingly, and we do the regression of our test only. We don't resynthesize or we don't rerun the test cases of different teams. They will just give the modifications, whatever the changes they did.
Good.
Accordingly we need to change ourselves. We need to change, maybe we need to add some switches in the sense, we will have some coverage analysis, or if you want to run the test in which position you want to run the test, like that we will have some switch commands in scripting language. According to that we will modify our test based on different teams, whatever the changes we got. In S4C verification, we already have the S4C verification syllabus, right? I will tell you what are the types of switches we use and how to write the test flow and how the test flow will execute and how the C test commands we write. Okay, these things we will discuss after system Verilog and UVM. Okay. So anyway, in the middle, while we are discussing these things, I am explaining you little bit in S4C verification level also to get the idea. So once we go to the S4C verification now, so you will get those things also. Okay. So whenever we connect these things in system Verilog or Verilog HDL, it is very difficult to connect everything in a static in nature, because even DUT in Verilog HDL, how we interface the test bench and DUT using, how we interface test bench and design using DUT, right? Design under test. That means whatever the DUT signals are there, test signals and design signals, we just interface using the design name. Okay, but in system Verilog, we don't use that, which is a static in the sense we are just interfacing manually. Okay, not taking bundle of signals in one class. Okay, in system Verilog, if we see separately, we use the interface block. Interface in the sense where we connect design and test bench with respect to the clocking blocks, with respect to the mode ports. Okay, so that everything is connected dynamically, where we can access through the objects, through the instances. Okay, so that is uh, that is not easy. If we talk literally, Verilog test bench is only easy to write, but there are a lot of limitations with Verilog test benches. Okay, if you go to system Verilog test bench, lot of things we need to write, put, like whole test bench architecture we need to write, and lot of blocks we need to write. Okay, so nearly thousands of lines of program we need to write in system Verilog. But in Verilog HDL, just 20 lines we can complete the test bench. Okay, but still, by using system Verilog, there are a lot of advantages. What are advantages and all, we will discuss once we start system Verilog. Okay, so for today, next question. So I think you got the clarity what is the synthesis and simulation, right? Synthesis is nothing but generating the circuit netlist. Simulation is nothing but for the circuit netlist, we apply the test vectors in the test bench and check the output and verify the output whether it is correct or wrong. If it is correct, we will tell like our design functionality is correct, our design is working fine. If it is incorrect, something mistake is there in terms of test or in terms of design functionality or in terms of connections. Okay, we need to recheck again and we need to make sure that whether our verification is correct or wrong. Again, for all test vectors, we need to check. That is what the difference between synthesis and simulation. Okay. Next, in Verilog HDL, what are the different data types we have?
Registered and net data types.
Register and net. Okay. In register, what are the data types we have? In net, what are the data types we have?
In register data types we have reg, integer, real, and time. Whereas in net data types, it is wire, WAND, WAND, WR. Yeah, some of the examples of net data types.
Okay. Wire is mostly used. W or W and also we don't use. And we have try row for buffers. That is also not helpful because we are not writing the CMOS level program, right? A CMOS level programming is not suggested in Verilog HDL. We need to write in behavioral, data flow, gate level. Okay, compared to these three, behavioral is mostly preferable in industry. Why? Because we can't write the program thousands of lines of program using gate level or data flow mostly used, and behavioral everywhere we use whatever the designs. Okay. So in these data types, what are the synthesizable and what are non-synthesizable?
Always
What?
is synthesizable.
Okay. Always is the data type.
No.
Jarin told 5 different data types. In that, what are synthesizable, what are not synthesizable?
For reg is synthesizable.
Okay.
Wire,
Wire. Okay. Jarin, can you answer? What are synthesizable, what are non-synthesizable? What is the difference between synthesizable and non-synthesizable? Synthesizable means which we use in the design,
right.
and non-synthesizable means which we use in the test bench. What are you doing without revising the concepts? Basics. These are very basics, right? Tell me what are synthesizable and non-synthesizable. Tushar,
Synthesizable are like wire registers that are actually converted to the net lists, and then non-synthesizable are like integers. I'm not sure about integers actually, or parameters or constant definitions that we write in the code. Those are non-synthesizable.
what about time real,
They are also not synthesizable.
which we use only in the test bench?
Test bench, right?
Okay. Next question. Sweta, can you tell me what are the different types of procedural blocks out there? Did you remember the concepts? You have joined newly.
Uh, I remember Blocking and non-blocking.
Not blocking and non-blocking. What are the different blocks, different procedures?
Always and
Mhm.
assign blocks. I mean, assign.
Always and
Assign.
design
Assign.
and assign. Okay.
Yeah.
Assign is not a procedural. Assign is a
Okay.
continuous.
Okay. Yeah.
Jarin, what are the different procedural assignment statements?
There are two procedural assignment statements. One is initial, and second one is always.
Which is synthesizable and which is non-synthesizable?
Always block is synthesizable, whereas initial is used in the test bench,
Test benches.
so it is not synthesizable.
Okay. Jivita, can you tell me what are the rules we need to follow when we use the procedural assignment statements?
In procedural assignments, for combinational circuit, we have to use, for LHS side, we have to use wire. Um, for output, we have to, in sequential output for outputs, we have to use the reg.
Okay. Why it is getting combinational or sequential now? I'm just asking about procedural, not whether it is combinational or sequential.
LHS side, we have to specify wire. RHS, either it is net data type or reg data type.
For which statements? For always? Is it for always?
No, that's for continuous
Okay.
assignment.
Assignment statement. Whenever we use assign, left hand side variables must be declared with the wire data type. Right hand side variables must be declared with wire or reg data type.
Reg.
Okay.
Yeah.
Okay. What about
For
procedural
always,
statement?
for always, we have to use. We must use LHS side reg.
Mm. RHS side?
Either wire.
Wire? Wire?
Yeah, wire or the wire.
Only wire? Wire or reg? RHS side, whether it's a procedural assignment statements or continuous assignment statements, whether it is a always or initial, right hand side variables can be wire or reg, anything. But in procedural, LHS side variables must be declared with the reg data type because we are using always block and initial block. Okay. Based on whether it's a combinational logic circuit, sequential logic circuit, the differentiation is clock. If we use combinational in always block, the inputs will be changed with the output will be changed with respect to the inputs. But if it is a sequential logic circuit, the output will be changed with respect to the clock, edge of the clock, whether you take positive edge of the clock or negative edge of the clock. Okay. So next question, how can we specify the synchronous circuits and asynchronous circuits in Verilog HDL? Suppose the question is asked like design a D flip-flop with asynchronous reset. Okay. Next question. Design a D flip-flop with synchronous reset. So how can you write a program? How can you specify that asynchronous or synchronous difference?
Reset is generally is nothing but force a design to a unknown condition after powering up. There are two types of resets. One is synchronous reset and asynchronous reset. If you specify in always block, always at the rate of passage clock, that is like a synchronous reset. Reset will happen only when it is synced with the clock. That is called synchronous reset. Whereas in asynchronous, without without depending on the clock, it will reset will happen. We will specify like always at the rate of passage clock or passage reset.
Okay. So in always block, we need to mention reset. Then it is asynchronous. If we don't mention it is synchronous, it will change with respect to the clock. Okay. Next, Tushar, can you tell me what is the difference between serial execution blocks and parallel execution blocks, and what are we use in Verilog HDL in procedural assignment statements?
So for serial and parallel execution, we use something called as blocking and non-blocking. So for serial uh, assignments, we use the greater than equal to symbol for non-blocking assignments,
I'm
which
just
happen.
asking what are the sequential execution statements, what are the parallel execution statements, how we can write within a initial block or always block. How can we specify those? What are the sequential execution blocks we have and parallel execution blocks?
I can't think of anything.
Jarin?
Sequential execution is done with the begin and end block, whereas parallel execution is done with the fork and join. So in sequential execution, in the execution is done sequentially, as the sequential is done execution is done sequentially as the statements are mentioned in a sequential manner, whereas in parallel execution, the execution is done concurrently.
Okay, correct. Today we will just discuss the theory. In the next session, we'll do some practical so that I'm not writing any codes here. Okay, so what is the difference between blocking and non-blocking, Sweta?
Um, so for non-blocking, we use for sequential circuits, like it execute in parallel. So blocked one we can use for combinational circuits. So execution will happen at a time.
Okay, why do we use sequential non-blocking assignment statements for sequential logic circuits? Why don't we use combinational? Tushar, can you explain what is the difference between blocking and non-blocking, the rules we need to follow?
Yes. So I think blocking statements are the ones that execute sequentially. So the rule says that uh, we use the delay parameter on the LHS, with, I'm not sure if it's for fork joint or. And then we use the is equal to symbol for blocking. For non-blocking, we use the lesser than equal to symbol, which does the concurrent execution. And
Okay.
and then for sequential, it happens, or for blocking, it happens line by line, where the whatever the on the first line, if the variable value changes, it affects this next line as well. But for non-blocking, it happens after the next clock cycle. And also for non-blocking, the uh, delay is on the RHS instead of LHS, I believe.
Which is the blocking and which is a non-blocking?
Blocking is on the left side, and the right side is non-blocking.
Jarin, can you tell me what is the difference between intra-assignment delay and inter-assignment delay?
Uh, for inter-assignment, the RHS side of the expression is evaluated first, and after the specified delay, it is assigned to the LHS side. Whereas for inter-assignment, for inter-assignment, the delay is first applied, and then the evaluation on the RHS side is done, which is assigned to the LHS side. So it basically is the difference in the delay assignment.
Okay. For blocking, which delay is used, and for non-blocking, which delays are used and why? Jivita, can you explain? What is the difference between these three codes and what is the output?
Okay, in blocking assignment, in blocking RHS evaluation and assignments both will happen at the simulation after time delay. Whereas in non-blocking, RHS evaluation is happen immediately, but the assignment will happen at the end of the simulation.
Okay. What is the output
Or
for fixed block?
A is equal to 20.
A is equal to 20. Okay. At what time?
5 nanoseconds, 5 time
Okay.
units.
Next.
B is equal to 12 at 7 time units.
Okay.
And C is equal to at 10 time units, C is equal to 8 at 17 time units.
Equal to 8. Okay.
Yeah, 8
Minus. Okay. Next.
at 17 time units. 20.
A is equal to 20. Okay. Is that correct? Others?
Yes, ma'am.
Okay. Next, for non-blocking, what is the output? Jerry, can you answer?
um, non-blocking at 2 units of time. Uh,
First
B
of
is
all,
equal to,
statements will execute sequentially or parallelly.
it will execute parallelly.
Okay, but we have used begin and block, right? Then how it will execute parallelly?
Um, right, sorry. Uh, fifth. Yeah, it should execute sequential.
Okay, if it is executing sequentially, first two has two statement at hash time 2 time units, B is updating, next hash 3 time units, C is updating, and next 5 time units, A is updating, 7 time units again, A is updating. So how it is doing if it is a sequential? Actually, blocking assignment is not parallel execution and not sequential execution. It updates the values concurrently, though it look like parallel execution, but it updates the values concurrently. Okay, because we are using the right side delays, right? So because of that, at what time the statement is executing and what time it is updating the value, we need to check. Okay, so these are executing concurrently. So what is the output now? At what time which statement will be executed?
So at 2 time units, B should be 12. At 3 time units, C is A minus B, which is -5. C value. C is
Okay.
equal to -5. For 5 at 5 time unit, uh, A is equal to B plus C, so which is 20.
Sorry. A is equal to 20.
Mm. And at 7 time unit, A B plus B, 20.
So what is the difference between blocking and non-blocking? Blocking means the delays will be added to the next statements, and also whatever the present value is there, that will be retained. That previous value will be stored based on the previous value only. We will do the next step. Okay, next expression will be executed on previous value. But whereas a non-blocking assignment, whatever the initialized values are there, it will consider only initial value. It doesn't return its a previous values. That is what non-blocking. And also the statements execute concurrently, so the delays are not added to the next statement. Okay, so that is what the difference. Whenever we design a combinational or sequential, as you already know here, blocking means it retain its a previous value. So while we are trying to do the shift operation, before I already told the example. Suppose um, D0 is getting some I value, and D1 is getting D0, and D2 getting D3 and D4 getting D2 getting D1, D3 getting D2. Okay, suppose if I value is 10, so this 10 is assigned to D0 and D0 again 10 and D1 again 10 is assigning here and D2 again D3 assigning 10. So same value, whatever the initial I value we consider, same value is getting at D3 so that it will doesn't work as a shift operation. That's why blocking assignments are used for combinational logic circuits. Okay, same block if you consider as a non-blocking assignment like there, like here, whatever the initial value is there for I equal to 10, that I equal to 10 is assigned to D0. Whatever D0 initial value is there, that is assigned to D1. Whatever D1 initial value is there, that will be assigned to D2. Whatever D2 initial value is there, that will be assigned to D3. So that shifting is happening. The values are shifting like this one by one. But in combinational, whatever the input I we have assigned, the same output is getting final stage. So that's why it is not preferred for sequential logic circuits. Non-blocking assignment is preferred for sequential logic circuits. Okay, so in the same way we can do the swapping operation in better way using non-blocking assignment. You already know how to do the swap operation. Just A equal to B, B equal to A. By using that condition, we can do swap. Okay, so clear till here? Any doubts?
No.
Okay, next question is for Jeevita. What is the difference between case X, case Z, full case and parallel case?
For case X, we'll treat X and Z as a don't case. In case, it will compare zeros and ones, whereas in case Z, it will treat Z as a don't case. In
Okay,
parallel case, only one case item it will match with the expression, case expression. In full case, we have to specify all possible conditions with a default also.
in parallel case?
In parallel case, only one case item it will match with the expression. Otherwise, overlapping occurs.
Okay, fine. So here case X and case Z, in the sense, first of all, case X we represent with the unknown value X. Z means we represent with the high impedance value Z. Okay, so here in case X, it just ignore X and Z, just take as a don't case. Okay, where we use, in the sense, mostly whenever you want to match with ignoring all unknown values. Okay, in priority encoders we need to check with the unknown values. That time we use the case X mostly. And case Z, it just treat Z as a don't care. So whenever it is useful, mostly in the whenever we want to match with the Z. Example in mask. So whenever we want to mask the data, there we use the case Z. Okay, so that is the difference. Parallel case, in the sense, I already explained, right? We put the question mark. Case same as a case Z. We put the question mark so that we generate the parallel scenarios at a time. Suppose here there is a 0, question mark, question mark. So instead of these two question marks, actually you need to generate 0, 0, 0, 1, 1, 0, 1, 1, 4 cases. This is what we call as a full case. Full case, in the sense, whenever we write all the conditions in a case statement, then we call it as a full case. Whenever we put the question marks, we call it as a parallel case. That means by using the question mark, we are generating the data parallelly. So in 4 cases, like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. In these 4 cases, whatever the value we have assigned, to here, that value will be assigned in all these cases. Okay, so that is what a parallel case and a full case. And next, in behavioral modeling, we use case statements and if else statements, right? So whenever we do synthesis, what type of netlist will be generated for case and if else? Tushar, can you explain what type of circuit will be generated whenever we use case and if else?
For case, it will be a regular mux, but for if else, it'll be a priority mux that will be generated.
Priority mux. Okay, priority mux means
It means it'll be like uh, from the mux, we have the first input of the mux will be preferred. So one of them, there'll be two muxes, and then the first mux will be connected to the second mux first input.
okay.
And this other the second input of the second mux would be, I think, either 0 or 1.
What type of operator it is?
Logical
Uh,
and
Logical, and what is the output?
1.
1. Next,
1. Logical or 1.
okay. Jerin, can you answer what is the output for this and this? And this. What is the operator it is?
Bitwise and
Bitwise operator.
Okay. What is the output?
One triple zero.
1,
Triple
0.
zero.
Okay. Next,
All ones.
okay. Next,
0011.
0, 0, 1, 1. Okay. It's a bitwise operator. Okay. Next, what is the output for first and second?
for the first one 1. 1.
1. What type of operator it is?
Reduction.
Reduction?
Yeah,
Reduction NAND. 1
reduction
into
and
0. 1 into 0, 0, 0 into 1, 1. Sorry, total 0. And finally, complement for 0, 1. Okay. Next, X
That's
naught
1.
X 1.
1. Okay. Next, What is the output for this?
5.
Tell.
5. 5.
Okay, can you explain?
Yeah, A is greater than B. It's false. So B minus A will execute.
Okay,
So 50%, 10, 5.
okay. Jarin, can you tell what is the output for this? Wait, Shweta will answer. Shweta, can you tell what is the output? What type of operator it is? Are you there? Okay, Jarin, you can answer.
Yeah, it's a concatenation operator.
Okay.
Mhm. Mhm. Give me a moment.
Hmm?
I'm just trying it right here first. It's easier to tell.
What is the value?
1101,
One
01,
101
0, 1110.
10. Okay. Why did you took this much of time, Jarin? Have you not remember?
Yeah, I remember, ma'am, but just take a little more time. That's it. I was writing it over here and then I was gonna.
Okay. Tell me the output for this, Jarin.
1101 3 times.
1101 1101 Okay, next.
Next 01 twice
0101
and
Then
1110
1110
again 1110.
1110. Okay. So is that correct? Others?
Yes.
Okay, fine. Next question. So I think operators clear for everyone, right? Any other
Yes.
doubts?
And I think
Okay.
the triple and percent symbol is a doubt. The three
Which,
times and
where?
operator, like when we use three times and
Uh,
operator, that
Arithmetic.
yeah, That is a little
3 times
confusing.
and not 3 times and it's a equality operator.
Yeah, equality operator.
3 times
That's
equal to. What is the
no,
difference between
I
three
think
times?
even 3 times and is also there somewhere. I've seen it once. Not sure.
Yeah, one is logical equality, and the triple equality is nothing but arithmetic equality or case equality. In logical equality, it will compare only zeros and one. If any of the variable contains unknown value, the output will be unknown only. Whereas in case equality, it will compare 0, 1, unknown, and high impedance values. If both matches, it will
Oh,
give result as 1. If it is false, it give result as 0.
Okay. So here triple equal to means it will check with the unknown values and high impedance value. Double equal to operator means it will check only 0, 1 values. If you it
got it.
doesn't check if you put unknown and z values. Okay. Like that we have not equal to, not double equal to and not equal to. Here also it will compare with the unknown value and high impedance values. That is what equality operator. And still we left with arithmetic relational operator. You already know arithmetic and
Yeah.
relational operator. And what operators are left? Okay, that's it. Next question. Mm, what is the difference between dollar display, dollar monitor, dollar strobe, and dollar write?
Dollar
Jevin,
display,
tell.
it will display immediate value, whereas in dollar monitor, it will observe every change of value.
Okay,
It will monitor and it print. Dollar strobe, it will print at end of the simulation time.
okay,
Dollar finish, it will terminate the simulation. Dollar stop, suspend the simulation.
okay,
And dollar right, it doesn't go to the next line. If you want to go to the next line, we have to use /n.
okay. Next, Tushar, what is the difference between dollar dump file, dump on, dump off, dump where's, dollar stop, and dollar finish, dollar time?
With the dollar dump, whereas I'm not sure. It usually creates a dump file for us to execute the simulation graph. But I'm not sure with the dump files dollar thing. But with dump finish, to stop an always execution, and the dollar stop is used for the same, and the fan dollar time is used to we can use it to print the time in the dollar display.
Okay, dollar dump file, dump on and dump off.
Not sure, ma'am.
See, dump file in the sense we are writing in the test bench, which file you are dumping. That means dump in the sense what to open the waveform. We are using the dump. We need to use this system task or simulator directives, whatever we call. Okay. In real time, if you go to some company, there also we will tell like, okay, we need to check dumps. We need to open the dump like that waveform. Nothing but whatever the variables are there, we need to check output and input variables. We need to check in the waveform. That's what we call as a dump. Okay. So dump variables means what? Dump var means whatever the variables are there in the design, we need to check those variables in the waveform. That's why we are dumping all test bench variables and design variables into the waveform. Okay. Dump vars 0 and 1 will be there. 0 means we will dump all the variables. 1 means we will dump specific variables like that. Or else even if you don't put also directly we can dump all the variables. Mostly we will dump all the variables. No need to specify 0 comma 1. Okay. Dump file means to this test bench which file you are going to dump. That means design file. We will put dump file. $dump file. Here we need to mention design name. Whatever the design name you are taking, design.vcd. VCD means what? Value change dump. Next, $dump vars. Here all the variables of test bench will be dumped. Okay. Here you can use the design.vcd or else you can use dump.vcd. Dump.vcd means directly we are dumping the variables, all variables in the waveform. Okay. In the waveform, you need to check according to the requirement. Okay. What variables are required. Okay. Based on that, we will just compile and check the all corner case scenarios using dump file. Okay. Did you understood everyone?
Yes, ma'am.
Yes.
Next, on off means what? Suppose here within the initial block, we are assigning some 10 is equal to A is equal to 10, B is equal to 20, C is equal to 30, suppose some value. We are telling here dollar dump on. So after dump on, all the variables will be simulated and it will show in the waveform. In some cases, we are just hiding the data. We just want to hide some values without checking it to the waveform. Okay. So those type of values, we will tell it as a dump off. Okay, dump off, so that we don't want to check those things in waveform. Here initially I am putting as a dump on. And after some time, except these scenarios, you want to check remaining all. Then again, you can mention as dump on. Okay. So this is how we can differentiate dump file, dump var, and dump on. Dump file, dump.vcd. That means all the file, entire file we are putting into the waveform to generate the variables into the waveform. Dump.vcd, value change dump. Okay. VCD means value change dump. Next, dump variables, dump vars. Dump vars means all the variables we are dumping. Okay. Next question. Task and function we didn't discuss. Task and function majorly we will discuss in the system Verilog. Why? Because there we will get the events, task and functions. We need to discuss there. And mostly problem statements we need to discuss, like how can we design the multiplexers in a simple way. We discussed already a lot of ways, right, for full adder, multiplexer, encoders, decoders, registers, counters. So next session on Friday, right? Friday we will have one more same mock. Okay, you need to practice, some more practice is needed. Okay. I expected like very good answers from your side, even from basics. Okay, but you forgot few concepts. Just revise all the concepts once again. Okay, so Friday we'll have one more mock on only on coding part. Okay, so you need to share your screen. Everyone join with the laptop. You need to write the simple snippets. Okay, I will ask the questions. You can write the program. So, and next, what are the things or there we discuss? Mostly Friday we will complete the mock. Okay, from Monday onwards we will start the system Verilog. Okay, so just revise these concepts. What are the questions left? So in counters, suppose how can you differentiate the register and counter in Verilog HDL program? Okay.
I didn't
Can you
get the
tell me
question.
what is the difference between always, forever, for each, for loop?
Always is a procedural statement, and forever, for loop, and all of those conditions are used inside procedural statements. Forever block will continuously keep evaluating the statements present inside it. It's mainly used in test benches and are only used in test benches. And with for loop, we use it. These are all non-synthesizable uh, statements or conditions that are used. With for loop, we can use it to like iterate the inputs, and with repeat, we can also do the same, but we can give uh, the value like repeat for 20. We can do repeat of 20 for clock in a test bench.
Okay, good. Okay. Next, like what is the difference between reg and wire data type?
A wire is nothing but a physical connection between circuits. It doesn't hold a value. Register is used to store values.
Okay. Okay. Next, coming to the Verilog, we need to discuss time scale concept also. Okay, so one concept is left in Verilog, time scale. We will discuss that time scale, or else I will share you the recorded session for time scale. Okay, just 5 minutes. Within 5 minutes, we can complete. Like there will be different precisions will be there. We need to understand each scenario, what precision we need to use. Mostly I will discuss in the next live session only, not recorded. So that one concept is left in Verilog. And okay, next, what is mean by sensitivity list in Verilog?
They are the values used in the always condition that executes the always statements. So based on the variables changing, the always block is executed if the present as the sensitivity list for that always condition.
Okay, okay, fine. Next question. Is the for loop synthesizable in Verilog HDL? Or else how can we do?
It is not synthesizable. We can make it synthesizable as a generate by using generate statement or
Okay,
generate condition with the for loop.
okay, fine. What is meant by a bad latch? How the bad latches are inferred in the Verilog, and how can we avoid the bad latches? Jerin, can you answer?
Bad latches is a condition where uh, when we are defining multiple branches in a statement, uh, some of the branches are not defined. For example, when we are using a case statement and there are four options to be defined, and if only three are defined, so there would be a case where in one of the statements the output would be latched, and that would create that that is called as bad latch. So to get avoid from the bad latches, we need to specifically mention a default value.
Okay, good, nice. So what about UDP? Have you practiced the UDPs in Verilog? We discussed some examples, right?
No,
Oh,
Okay. UDP is not high priority. We can avoid, but just conceptual wise, we can understand. Okay. So these are what Verilog concepts theoretically. Just we covered theory as of today, and In the next session, we will discuss on some coding questions. Okay, so do practice. Okay, you need to write the program. So that's it. Any doubts from your side?
No, ma'am.
Okay. Okay, then. Thank you all. Bye. And
Thank you, ma'am.
also, I will share the assignments for FSM. I didn't share it for FSM till register and counters. I have shared. So FSM is left over, and memories we already discussed before memory. You just work on RAM, ROM memory. Already discussed, right? That will be enough, and I will share you the coding test link. So today, just mock interview is completed. I will share you the test link. You need to attempt the test. Okay.
Okay.
Yes, ma'am.
Okay then. Thank you all.
Thank
Bye.
you.
Thank you, ma'am.
Thank you.